Hello and welcome back to the Countering Climate Skepticism podcast, episode number 4. Have you got fed up with hearing about climate change not being taken seriously? Maybe you find yourself arguing with people, either online or in person, about climate change. Have you heard people say it's natural or climate change has always happened, right? If you're anything like me, this can make you feel pretty helpless and demoralized. So this podcast is our attempt to help address this problem. We aim to provide the counter arguments in the climate skeptics playbook and give you the basic knowledge to counter all the nonsense put forth by climate skeptics. My name is John, a history teacher, and with me is my co-host Mark, a climate researcher. How are you doing, Mark?
Not too bad, John. I have been busy this week attempting to insulate my family's home, insulate the loft.
Oh, nice. Doing it yourself, are you?
Yeah, I thought so. Yeah, like I have a load of this stuff called carpet underlay, and it was kind of an accident, really. I just ordered like a little sample, and the company that sent me it, so I paid £1 for like a little sample, and they ended up sending me, what was it, like 15 square meters?
Nice.
Yeah. It was like, my mum was like really confused when this sort of got delivered, and and it's worth like 60 quid, but it's just a mistake that the company made.
Nice.
So I was trying to figure out how to use it, and I've sort of always been thinking about my family home, and it's it's like you put the heating on in the winter, and it sort of heat escapes the house pretty quickly. So I was thinking about ways in which you could maybe insulate it, and I was thinking about the loft for a while, but the problem with the loft is if you put like too much insulation down on the floor, you sometimes risk the pipes freezing.
Oh, right. Okay.
So I thought that maybe I could use like a very powerful staple gun and like staple this carpet underlay to the actual like wooden rafters that go up the inside of the loft. And I sort of sanity checked this with a builder first. I said, could this work? And he was like, yeah, it's a good idea. So I'm perhaps gonna do this over the next few months before the winter temperatures hit in the UK.
Nice. No, well, rather you than me. Like, I absolutely hate getting up to do work in the lofts. It just gets so dusty and filthy up there. I mean, before we went traveling, one of our jobs was going to be to board the loft because we were going to have that as a storage area while we rented out our house. But I ended up paying somebody to come and do it themselves, and it turns out they did it for not too bad a price, far quicker than I would have done, without all the stress and effort that I would have had to have done. So well done you for getting stuck in with it. I mean, since we've come back, we've been trying to be a lot more conscious when it comes to energy use and wastage. We had to buy a whole new like kitchen set, so like washing machine and fridge and everything like that. And it's just crazy how difficult it is to actually find those machines that are actually like low in energy kind of expense, which is something that I've been trying to be a bit more conscious of now that we're back.
Okay. From my mum's house, I managed to persuade her, like back in the day, to get, I think it was like, it had an energy rating of A++.
Yeah.
So we have like a freezer in our kitchen, which it's from a German firm. With Brexit, I don't know whether it's as easy to get hold of, but like if you let me know if you want the make. But it probably, I think the problem is that it costs a lot initial outlay. But just over the years, you'll save money because a freezer's always on.
And yeah, absolutely. And something that I noticed doing a little bit of research and digging into it in myself is that they're quite sly actually. The energy efficiency is not the same as their rating for how much energy they use.
Oh, what? Really?
So I noticed this. I ordered something that was like AAA for energy efficiency.
Yep.
But then it was graded as D. Under the energy scale. So yeah, that's something to look out for. Like dishwashers and fridges, they just use up so much energy. When we were out in the States, actually, something that is kind of a really long-term goal for my wife and I, but something to be quite exciting if we do get to this point. When we were in New Mexico, we were just driving through the desert, and we saw these crazy like alien looking houses, and we were like, what the hell are those? And it suddenly occurred to my wife Lisa, because she'd seen TV programs about them. They're what they call an Earth ship. So they're off-grid, entirely self-contained, renewable buildings. So
Right.
the walls are made with a base of recycled tires. They then like build and sculpt the building on top of that. They are entirely self-heating, so they use like solar to generate their heat and electricity. The natural windows generate enough light in order to grow plants and to have a greenhouse growing in there. And the whole water system and everything is all run through rainwater. So it collects rainwater and cycles that through. So, you know, we were just absolutely amazed with these buildings, and just thought, yeah, that's something as somebody environmentally conscious like us would like to work towards. You know, can we get to that point of having an entirely self-sufficient house with its energy use?
Yeah, that's really inspiring, and it sort of goes against the, I guess, cliche that, you know, Americans don't care about the environment so much.
No. I mean, they were saying, we were asking about where they get built, and they said that they do actually build them across the world. Just some places are just much trickier for getting planning permission and more red tape and stuff. But they do have some that they built in the UK as well. So, you know, maybe one day we'll be able to save up enough to just buy a plot of land and start getting building.
Yeah, good luck to you.
Cheers. Okay, so what about any climate denial confrontations you've had this week? I'll say confrontations. Well, they're mostly confrontational, aren't they?
You know, John, one week you will ask me that question, and I'll be like, I've scoured the internet, and there's just nothing out there this week. The climate skeptics, deniers, contrarians, they're all on holiday. But this week won't be that week, John.
Okay.
And so a couple of days ago, I was one in particular struck me. I mean, it's one that you hear a lot, and it's this kind of, as you and I know, there's a sort of consensus among scientists who study the climate, something like 97% of them, and sometimes you see it's even higher depending on, you know, how you measure it, but 97% of them agree with the statement that the Earth has warmed, and that this warming is human caused, or mostly human caused. And so you get a type of argument that goes something like this. You know, well, Galileo was, you know, like, he was in the minority, and he ultimately was right. He was vindicated, you know, maybe even after his death. So therefore, we are the Galileos of our modern time. You know, we're being ignored. So it's
even I've come across that kind of argument. I'm just a misunderstood genius.
God, it's amazing how many misunderstood geniuses there are out there.
Yeah.
And I mean, this particular one, he wasn't referring to Galileo specifically. He was mentioning the science of the history of the science behind, like, tectonic plates moving. And this is actually like a really interesting case study, because, you know, we didn't all, like, people know that over very, very slow periods of time, the Earth's continents move about. And then, you know, if you go back hundreds of millions of years, you can't even recognize the plate configurations. You know, like India, sort of over, like, I don't know how many tens of millions of years, it's been slowly, you know, sort of crashing into sort of Asia. And then you get the Himalayas, like, pop up because of this collision, essentially. But it's just happening so slowly. But so like, you go back 100 or 200 years, don't know exactly when, but I guess we must have thought that the way that the Earth looks now is the way it's always been. So we didn't know that, like, there was this movement, this tectonic movement, and then some scientists worked this out, or some group of scientists worked this out. Sorry, I'm not that familiar with the history of it, but I think when they initially said, you know, this might be happening, like, they were ridiculed even within the scientific community. But ultimately they were right, you know, and they managed to get, you know, like, other people to see this. So this sort of thing, you know, this kind of, like, I guess, Galileo type of thing does happen. But the difference between that and what the self-proclaimed sort of climate denier Galileo types out there, the difference is this: when there is something like this in science, It's essentially one scientist, who's sort of qualified up as a scientist, will then try to convince the scientific community that they are right.
Yeah.
And this will happen sometimes very slowly. I mean, there is even this one saying, which I find a little bit funny, that sort of science proceeds one coffin at a time. So it can, even, amongst scientists, like, even though someone is right, old ideas sometimes, die very slowly, but they do ultimately die. So when you look at climate skeptics or scientists, it's climate skeptics or deniers, the first thing that you notice is that the majority of them, the vast, vast majority of them, are not scientists to start with. So they don't really have scientific training. Or if they do have scientific training, it's not really in sort of climate science. And they haven't published any research, in that field. But then you do have there are a few famous names within climate science where you have like published authors who dissent from I guess you could call it the consensus among the majority of the fields. They are not convincing to the rest of the scientific field. And like, people have actually looked at their papers. And first of all, what's interesting is that they don't agree on an alternate cause. They have all different numbers of causes. So they're not even agreeing on what the alternate cause to the warming that we see is. And then in addition to that, when you actually look at their papers' methodologies and the data that they've used, typically there's this enormous problem with it. Like, they've missed out a whole chunk of data, or the way they've done their statistics is just fraudulent. So it's actually quite, you get people write papers or reports on what's wrong with certain, they managed to get it through peer review, and it's in journals, and it hasn't been retracted necessarily, but it's kind of known to be problematic. But yeah, so I mean, if you're a climate skeptic and you're a published author, that's one thing. But it's just the people, most of the people saying that I am a Galileo, they're just not scientists. and also, like, even amongst the sort of like the people who are published authors, the people that they're sort of, complaining to and talking about their theories tends to be the deniers outside of the scientific community. So they are basically not really engaging with the field. So sorry, even then, the chances that they are there's always a chance that there's a Galileo, but a Galileo is pretty feckin' rare. I mean, just can't account for all the Galileos out there, John. I'm sorry.
Yeah. So let's move on with our topic for today. What's on the menu for today, Mark? What are we looking at?
Right. So the previous two episodes that we've done have been about the first level of the climate denial ziggurat, which is, John?
First level is, you put me on the spot here, that climate change isn't happening.
Yes. So global warming, the temperatures aren't going up. They're flat. They haven't changed.
No, never happened. Didn't happen. Debunked in the last 2 weeks. Next.
Exactly. That's kind of what they're like. So anyway, so that's the first level. So now we're moving with this episode and the next one, we're moving on to the second level. What's the second level?
That if climate change is happening, then we didn't do it.
Exactly. Yes. The last two episodes, when we were doing level one, that the climate isn't changing, or maybe it's getting cooler even, there were a lot of different arguments, sort of subtypes of this. So again, and I'll include this in the show notes, Skeptical Science, there's a website, there's a list of 219 different denial arguments. So basically they show them and they give you like a one-word sort of like rebuttal to each of them, but you can actually click on each of the arguments and then you can sort of read at different levels of complexity why they're false. But it's quite good for this podcast because I can sort of look through, gather up all the arguments that are relevant, and sort of like classify or like put them, organize them a little bit.
Okay.
And so we did that with level one, and there were, for level one, I think, out of the 219, 53 of them were saying that the climate hasn't warmed or that it's gotten cooler. So that's about 24%. And then 40% of the 219 arguments, so 87, different arguments were about level 2, saying, so the warming has happened, but it is definitely not to do with human-caused greenhouse gases like CO2.
Okay. So we're basically talking like over a third of all arguments being made are around it isn't us.
Yes. So it's probably the biggest layer of the ziggurat in terms of arguments, because I think, as I said last week, the idea that the climate isn't getting hotter, I don't think flies. So it's if a denialist or a skeptic is wanting to talk about that, like, people will say, come on, mate, like, just look at the news, or it's obviously changing. So it's I guess they have more luck if they just say, it is warming, but it's not us. Therefore we can't do anything about it, etc., etc. But even this layer of the ziggurat, like, people are getting wiser, and in the UK, I think most people know that it is human-caused CO2 predominantly that is the cause. So okay, so if we ziggurat level 2. It is warming, but it's not us. If we break down that into like various different subcategories, I've got 4 subcategories for you, John. The biggest one is, of which we have 34 separate arguments, is that it is not human-caused greenhouse gases. Okay. For example, volcanoes emit CO2. They emit way more CO2 than humans. That's an example argument. The second subtype is other causes, and there are 28 of those in the list. For example, the sun is getting hotter, and that's what's causing the climate to warm. Then you've got 15 arguments that sort of suggest the warming is happening, but it's a natural cycle. I mean, you've got various different ones here, but one of them, for example, is we reckon it's a 1,500 cyclical thing where it gets warmer and it gets colder.
So just to clarify for all our listeners, any new listeners as well. So these are all arguments then that over the course of this episode and next episode, we're going to debunk, and we're going to be saying how these aren't actually correct.
Exactly. Maybe not quite all of them, because there's 87 of them, but that's why it's important to put them into a sort of, to organize them a bit and to take representative arguments, and then by hearing how this is debunked, you can apply this to sort of variations, because there are just infinite variations. And there's a remaining 10, basically like other types of, like, sort of a hodgepodge of different things. But like, one example is some of the arguments are that it is CO2, is carbon dioxide, but that carbon dioxide is not produced by us. And then you have the usual ones that I think we had last week or last time, which were just misleading claims, or ones that questioned the data, because it's always easy to question the data. So truly a dizzying array of climate skeptical arguments. So in today's episode, we're not so much going to look at the various different arguments here. We're going to first of all get a more firm footing on what the science actually says about the causes of the current warming that we're seeing. So the idea is that in this episode, if you listen to this and you absorb the information here, then you'll have like a kind of a foundational knowledge, and that will enable you to sort of maybe more critically evaluate claims that conflict with that. First of all, the climate skeptics love to say climate has changed before, implying that it may be warming now, but this warming is nothing new in the context of Earth's history. And they are correct that climate change has happened before, that the Earth's climate has, over its long history, it's gone up, it's gone down, it's done various things, and humans weren't involved then. They are absolutely right. But before we deal with the second part of that, so basically the implication that they make is because it has changed in the past. Therefore, it can't be humans causing it now. That's a little bit of a non sequitur, which I think we dealt with maybe in the first episode, non sequitur logical fallacies.
Yeah.
But I'll explain a little bit more later why this is a fallacy. But first of all, I'd like to divide up Earth's history into 4 different periods, from the closest in time, working backwards to make the following discussion a bit simpler. So the very closest period of history is the period since 1850, since the Industrial Revolution, where we discovered coal, oil, and gas, and we started to burn them to drive our economies faster and faster and increase our productive output. So that is, I'd refer to that historical period as the current warming. If you go back before that, so say from the beginning of the last 20,000 years ago to 1850, I'd refer to that as the near past. So you're a history teacher, John. This would maybe be a bit of a different scale for you, because I doubt you would say 20,000 years ago was the near past, would you?
No. But I mean, so we're talking about the end of the last ice age around then, aren't we?
Yes.
Yeah. So I think it's my understanding that I think Homo sapiens have been around for approximately 200,000 years, and so the last 20,000 years is when we then see this explosion of human activity after the last ice age, when we discover domestication of animals and farming.
Yes, exactly. So even though that's still a fair way in the past, I'm referring to all of that in a climate context as the near past. If you go back further than that, you have the intermediate past. And the intermediate past starts 1 million years ago. So the intermediate past is 1 million years ago, all the way to 20,000 years when the near past starts. Going back further than that, say from 60 million years ago to 1 million years ago, this is the deep past. And then before that, and it's funny, like 60 million years ago, the last 60 million years have been just 1.3% of all of Earth's history. It's amazing.
It is. Yeah. I mean, like when we were traveling across the States, I think I bring this up every episode, but when we were visiting the Grand Canyon, and they were talking about how the Grand Canyon is something that has formed over the last 6 million years, but the erosion rate for the Grand Canyon has been about the thickness of a piece of paper per year.
Wow.
And yet you've got this canyon that's like 6,000 feet deep. And it just blows your mind when you think of like how long geological timescales actually are.
Exactly. Yeah, it's nuts. So even 60 million years ago to the Earth, that's like no time at all.
Yeah.
But yeah, and before 60 million years ago, I think we know something about the climate prior to that, but it's obviously much harder. There's not much, fossil records are obviously not there, or to the same extent as the more recent past. The Earth, because of tectonic activity, the Earth kind of like eats itself up, and you lose all that stuff in the rock records. So it's before 60 million years ago, it's a lot harder to do climate research and to know what was happening to the climate. We do have some idea, but anyhow, it's most of what we're going to be referring to today is sort of in that 1% sort of closest to us in time.
Yeah, so, I'm just gonna fact check myself as well.
Oh, right.
I was wrong over humans having existed for 200,000 years. It's actually 300,000 years we emerged from Africa, but started showing modern behavior between 160 and 60,000 years ago.
Right. Look at that. Isn't that superb behavior? Fact checking yourself. Yeah, that's hats off to you, sir.
Yeah, I've evolved to the point of fact checking myself, unlike certain other human beings.
Can't imagine who. I should do a bit more fact checking of myself. I mean, in later episodes, no doubt, all the mistakes I've made will come in a torrent of emails, and I'll have to suddenly.
I wasn't talking about you, Mark. I was talking about Trump. But,
Oh, okay. Right. Yes, hopefully I'm a little better than Trump in my podcasting.
Yes, absolutely. We set the bar low on this podcast.
That is some level to set it at, but fair enough. Okay, so John, do you remember? Sorry, I feel like I'm putting you on the spot a lot here, but do you remember the current rough average temperature of the world today, John?
I don't remember, but I seem to remember it was colder than I was expecting. Was it something in the 20s?
Not bad. Maybe? Yeah, that's kind of close. 15 degrees.
Yeah. Okay. Yeah, I didn't remember.
I'll
write it down for next week.
It's fine. I mean, it's just one of the useful numbers to have, because it's like, quite. I mean, it's a very sort of like broad number, obviously, because you get it's hotter on average. It's not 15. It's usually hotter than 15 degrees at the equator, and it's usually colder at the poles. But yeah, sorry, it might be 14, but it's something like 14 or 15. Right. So if we go to slide 2 of I think this was the slideshow from episode 2, the PowerPoint, and this will be in the show notes, both in this week and episode 2's, if you want to look at it with us. So let me know when you brought that up, John.
Yeah, I've got it.
So this particular figure shows us the last 60 million years, the deep past onwards, and it actually breaks it up into the intermediate past and the near past, and even the current warming. But the x-axis, changes its scale, so you can have all of those on the one graph, and you can see that 55 million years ago. So, like, we're talking 10 million years after the dinosaurs died out, Earth's average temperature was a fair amount higher. Like, how high was it, John?
What year were you looking at, sorry?
So 55 million years ago to 50 million years ago.
So is this when there's that little spike?
Yes, and just the hump, as it were, as well.
Well, the spike shoots up to maybe about, was that 23, 24 degrees above what we have now. And then the temperature on average, other than that spike, is around about 15 degrees warmer than it is now. Okay, so I guess we should sort of talk about Fahrenheit as well. So if we talk about 15 degrees warmer, in Fahrenheit, I believe that's 59 degrees Fahrenheit warmer. Okay. And sorry, just to go back a little bit, I said we were talking about the Earth's average temperature. That's also 59 degrees Fahrenheit. And sorry, what did you say the increase was? Was it 20? 15 degrees warmer than it is now.
Right. So it's
in centigrade.
So it's 59 degrees Fahrenheit, and then there's the average temperature now is 59 degrees Fahrenheit, and then back 50 million years ago, the temperature then rose another 59 degrees Fahrenheit to 86 degrees Fahrenheit. Is that right?
We're talking about 15 degrees centigrade more. Yeah. Okay.
Yeah. Sorry, I hope we're not making this too confusing with centigrade.
So it was on average 30 degrees for the average temperature around that time. So yeah, wow, that really is hot compared to what we have now.
Yeah, certainly. I mean, like 1 degree is a huge change in the climate system, and like when they talk about like catastrophic global warming now, what they tend to be talking about is like greater than 4 degrees, or like the highest you sort of see is like +6 degrees centigrade. So 4 degrees would be 39.2 Fahrenheit. Am I getting this right? Would 4 degrees be? Hang on, I might be getting this wrong. Apologies if we're getting this. Yeah, that's obviously too much, isn't it? So a 4 degree increase is. Sorry, I got a little function on my calculator which like switches between centigrade and Fahrenheit, but it's obviously not working for like changes in temperature. So I think
because you can't, because 30 is, you have to take off 30 and then double it, don't you? So it would actually be, so because like 30, or is it 32 or Fahrenheit or something like that, is 0 degrees centigrade.
Yes.
So you have to take that up. Well, who came up with that system, honestly? Zero is when things freeze. That makes sense.
Yeah. Okay. So
100 is when things boil. if you're water.
Let me see what 1 degree. Sorry, I might record this bit just because we've confused things a lot with the Fahrenheit. I think it's when I think I get into a model when I talk about change is in degrees. So if it's one.
On a side note, if it's 15 degrees warmer in the future, that's really going to feed into all those conspiracy theories that the royal family are actually lizards, because they're gonna love living in that temperature.
Provided they have some shade, I guess.
Yeah, I guess. Yeah.
Right. Sorry, I'm gonna maybe redo this bit just so that I can be a little bit clearer with centigrade and Fahrenheit.
That's actually true, by the way. The royal family aren't actually lizards. I don't have any factual evidence to prove that. So it's 59 degrees Fahrenheit on average now.
Yeah.
And then we're adding whatever 15 degrees Celsius is to 59 degrees Fahrenheit.
Yeah, so basically, if you want to do the change, you have to do a different calculation, and it's 15 times 1.8. So 15 degrees centigrade, just for any American listeners, equates to 59 degrees Fahrenheit. So that's like the Earth's average temperature. So slide 2 of the PowerPoint presentation we had in week 2 had a diagram showing the Earth's climate over the last 60 million years. Do you have that slide up, John?
Yeah.
Good stuff. When was the Earth's temperature the highest, according to that graph?
In that, I can't remember what you called it, but that period of 50,000 years where there's a blip that shoots up, that went up to maybe as far as 24 degrees centigrade above the average temperature now.
24 degrees centigrade or Celsius?
Centigrade.
Celsius, yeah. Centigrade and Celsius are the same thing, right?
Yeah.
We're not wrong on that. Okay, so in Fahrenheit, 43 degrees Fahrenheit above what the temperature is now. So it'd probably be quite close to 100 degrees Fahrenheit.
Wow.
And so 35 degrees or something like that in centigrade. So wow. So the Earth's climate has been
cooking
bloody hot before, right?
Yeah.
Yeah, currently, I think when we talk about like global warming now, we've raised the temperatures about 1.1 degrees or something like that. If we raise them 4 degrees centigrade, 4 degrees centigrade would be 7.2 degrees Fahrenheit. That would be pretty catastrophic for like humanity, global civilizations, and if we raise them by 6 degrees, that's like almost 11 degrees Fahrenheit, like all bets are off. So we're not even talking about that. We're talking about like 15 degrees or more than that in the distant past. So the Earth's climate has been hot before. So no one in the scientific community is denying that the Earth's climate has been very hot before. I think you just need to, if you want it to be hotter than it is today, with the fact that we've raised it by 1.1 degrees or almost 2 degrees Fahrenheit, I think you need to go back something like 100,000 years or more to get to a time when it's been hotter than today. So if we look back, so this figure, for those who are with us for episode 2, it's interesting because it has 60 million years of Earth's climate temperature data, but it splits it up into the deep past, and then you get the x-axis sort of changes, and then you get the intermediate past, so like the last 1 million years, and then you get the more recent past. So the scale changes as you go along the x-axis. So tell me, John, what's happening in the intermediate past? So that's like between 1 million years ago and 20,000 years ago. What's happening to the Earth's climate?
It's fluctuating up and down, but in general, it's stable. And it's generally stable between like the same temperature as now down to -5.
But that's still a hell of a lot, right? Like
as in when I say -5, as in like 5 degrees less than what it is on average now. So yeah, I mean that is a massive difference. When you're saying that +4 degrees will be disastrous, presumably -4 degrees also has a significant impact.
Yes. I mean, if you go back, if you reduce the Earth's average temperature by 4 degrees, that's like 20,000 years ago when ice sheets would cover like the northern half of the UK. So right down from the poles all the way to the middle of the UK or something like that. There was just this enormous ice sheet sitting on top of the Earth.
So kind of a bit like Hoth in Star Wars then.
Yeah, I suppose. Does Hoth have any part of it that's like not
No,
under
probably
ice?
Probably not.
Right. So sort of like halfway on its way to Hoth then, I guess.
Yeah. Half a Hoth.
Half a Hoth. Yeah. I mean, like, I think actually, funnily enough, I think this is why when I was talking before about like we don't know much about Earth's climate prior to 60 million years, but I think we do know some things, and the thing that made me realize that is that I think they theorize that there's been a couple of times in Earth's history where it's been what's known as a snowball Earth.
Right.
So, or they think that the Earth was a snowball Earth. So basically, it would have been Hoth. You know, it would have been just completely white. If you were an alien spaceship and you sort of zoomed by, it would have been just, yeah. So,
just really drives home just how fragile our whole existence is, really.
Yeah, exactly. And like at that time, when it was covered in ice, you know, the Earth would have been the same distance from the sun. You know, so it's not as if, you know, anything major like in terms of orbits would have been different. But it's just that, you know, climate is a complicated thing, and you know, and we're going to learn more about like, you know, how climate changes. But essentially, you know, it's greenhouse gases are a big part of this, and greenhouse gases, even before humans come along, they play a very important role. But yeah, we'll get into that. Yeah. So basically, it kind of oscillates, right, in the last 1 million years.
Yeah.
How many oscillations in that period of 1 million years would you roughly count?
Does an oscillation include going both directions or just one way?
Both directions. So sort of an up and a down would be one oscillation.
10?
10, yeah. So that's an oscillation, an up and a down every 100,000 years?
Yeah, pretty much, yeah. Yeah, I see where you're going with this as well then. So the scale on this map, it's not to scale, as it were, because it has like 60 million years to 1 million years, then has 1 million to 20,000, then 20,000 to 0. So
Correct.
The fact that there is this kind of, over the last 20,000 years, it being cold and coming up again, although it looks like it's happening quite slowly, if you were to put it on the same geological time scale as the other scale, it would be part of that natural oscillation back up again. Would that be right?
That's correct. So if you expand out the time series or the x-axis, even like an abrupt rise over like a very long period of time would suddenly look very gradual. So this is an important thing to bear in mind. Right. Okay. So an impromptu scientific experiment for you, John, to conduct in your own head.
Okay.
So this is the episode of me putting you on the spot. I apologize.
That's like when the teacher says to the science pupils, right, we're going to do a practical, but you're going to do it in your own head. It's like, oh. Okay.
Yeah. I apologize because it's ironic because I'm the one holding a beer, and it's going to be about beer cans. And you know,
rubbing it in.
Sorry.
Rubbing it in.
Yeah. I feel bad. Although I was with you in GCSE chemistry, and I remember you doing something crazy with some sort of like acidic solution, and then
and it exploded. And
yeah, and it like fell on, I don't know, people's clothes or something. Like I can't remember exactly.
Yeah.
Oh, so.
Oops. Yeah, it's probably just as well I didn't carry on doing A-level chemistry, isn't it?
Well, in any case, we're going to be doing a bit of, I don't know, this is more like physics, but yeah, I give you 2 beer cans and you take one outside and you put it in the sunshine.
Okay.
And then you take the other one.
I'm double parked, beer in each hand.
Yeah. So you put your one outside, and then the other one you put in a cool corner of some room where there's no sunlight.
Okay.
You leave them there for a couple of hours, maybe like 3 hours, and you open them both. Do you have any idea what would happen, or like which?
Well, I drink the cold one first, obviously. Yeah. Well, yeah, I presume one would have, in the metal can, would have warmed in the sun and continued to warm, and the one in the cold would have warmed, but much slower.
Yes. What about when you're opening them? Do you think you have to be more careful with one than the other?
Yeah, I'm not sure how it works though. I presume maybe the one in the sun would be more likely to explode.
That's correct. Yes. So basically, this happens because. So do you know? First of all, do you know what gas is in a beer?
Is it CO2?
Yes, it is CO2. So any carbonated drinks, the gas that comes out of it is carbon dioxide. And if you have a Coke and you burp, that's basically the carbon dioxide that they use to make it fizzy. So essentially.
Hang on, does that mean that the more Coke you drink, the more you're increasing the CO2 in the atmosphere?
I guess, maybe. but I wouldn't worry about it because it's going to be a very, very small amount.
Okay.
Like when people are worrying about like carbon footprints, I don't think, there's some...
Yeah, they don't really ask you, how many Cokes do you drink? Yeah.
And even if it was, I mean, like, telling people, sorry, you can't have beer anymore. I mean, like, people would just be like, climate change, bring it on. If we can't have beers, I'm sorry. Life's not worth living. Yeah. So essentially, as a liquid gets warmer, or sorry, if I put it the other way, if a liquid is cold, it can contain more carbon dioxide in itself.
Okay.
So if you have like a Coke that's quite cold, and then you warm it up, the liquid won't be able to contain the amount of carbon dioxide it's got in it. And so it'll have to degas that carbon dioxide. And so in a beer can, the little area, the little volume above the liquid will then be like really full of this degassed carbon dioxide. Okay, so essentially we've learned that warmer liquids can't really hold as much carbon dioxide as colder ones. With this knowledge here, John, what do you think might happen to the world's oceans as the climate warms up?
So I presume they can't contain as much CO2. I presume, is it just CO2, or are there other molecules or atoms that they can't keep hold of?
So it's probably other sort of gas. So there are sort of various gases in the atmosphere, and a certain amount of those will be absorbed in the world's oceans. So I think it happens to all the gases that the oceans contain. But essentially, because it doesn't really matter about oxygen and nitrogen because they're not greenhouse gases.
Yeah.
But with carbon dioxide, yeah, you're right. As the ocean surfaces warm, they end up letting out a little bit of the carbon dioxide that they have trapped within them.
Okay.
Basically, so for this 1 million years, the climate has gone it's got hotter and then it's got colder about once every 100,000 years. And this was obviously way before humans were around burning fossil fuels. So did you have any inkling on maybe what maybe caused that?
Is it potentially slight fluctuations in the Earth's orbit?
You're absolutely right there. A+, sir. You've got about 3 different types of variations of the Earth's orbit. So the 2 that are easiest to understand is you sort of think that the Earth orbits the sun in like a perfect circle.
Yeah.
But we don't quite orbit the sun in a perfect circle. There's we're at some point
elliptic
in the Earth's
orbit.
Correct, yeah. but it's fairly close to a circle. So you wouldn't notice it if you were like looking down, but like there's like a little bit of a, and just in the same way that like the Earth isn't a perfect sphere. You're actually, the equator?
Squashed. Yeah.
Exactly. Yeah. So sometimes, I think these orbital variations they vary very, very slowly. So like over 40,000 years or 100,000 years. So the Earth's orbit goes from being more circular to a little bit more elliptical, and then back to circular and elliptical. And then another sort of variation in orbit is so the Earth isn't exactly, if you were to sort of, you have the sun in front of you and you have the Earth next to it. Do you think that the North Pole would be pointing directly upwards and the South Pole pointing directly downwards, or?
No, it's slightly offset, isn't it? Because we spin slightly on an angle on the axis.
Correct.
I don't understand the difference, but then we also have a magnetic north as well as the actual axis north as well, don't we?
Yes, that's correct. Yeah. So we're the Earth is not like straight up; it's inclined by something like 23 degrees, and this tilt gives us our seasons. In the UK, it's we're quite far north, so our summer days are 18 hours long, 16 hours long, and our nights in the winter, at the peak of winter, are 16 hours long. So yeah, big variation.
Really, you notice the difference in that, being in Europe as opposed to North America, because you don't realize, like it hadn't occurred to me, even when we were really far north in America, in Washington state, the days were still far shorter than we have here in England, like in the summer. So in England, it'll still be in the middle of June, it'll still be like sunshine at like 11 o'clock at night, but quite regularly in June and July in America, the sun was going down by 9 p.m. So it's crazy how much of a difference that makes when you're further or closer to the equator, further from the poles.
Yes. It must have been one of the many shocks of being in America for you, John.
Yeah. And almost being shot out in the woods, but yeah.
Really? Jeez.
Yeah, this family cracked out some AR-15s and started shooting them off into the woods. Yeah, we left quite quickly.
Presumably they saw where you were and weren't directly aiming at you, or?
Well, no, they were quite annoyed that we were in the way of their targets, and they said as such, asked us to leave.
Bloody hell. So did they fire shots, or was it just like harsh words, or?
No, they were firing shots. Yeah.
And they were in your general.
Not directly at us, like they were going past our heads, though. Yeah.
Oh, that's fun. Insane.
Yeah.
Were you being cheeky, or?
No, we said, oh, terribly sorry, don't want to walk through your campsite. And they said, yeah, you best not. We've got guns and axes.
Bloody hell.
Yeah.
But just for the record, most Americans you met were lovely people.
Oh, yeah. The vast majority were.
Wow. Anyway, I'm glad you survived that, because obviously yes. you weren't meaning anything.
Otherwise, this podcast wouldn't be happening. Yeah.
It wouldn't. No, it certainly wouldn't. Okay, interesting tangent. Yeah, you at least in the UK, the weather might be a bit worse, but hopefully no one will shoot at you. Yeah. A school might collapse on you, but you won't get shot. Okay, so you have these changes in orbits, and what that does is it slightly changes how the sun's ultraviolet light lands on the Earth. It sort of redistributes it between the equator and the poles. So this is a sort of a tiny change, but what then happens is it causes certain ocean currents to change, and as a result of that, certain parts of the oceans warm up. And when they warm up, you get a bit of an outgassing of carbon dioxide because it can't hold as much. Carbon dioxide is released from the Earth's oceans. Carbon dioxide is a greenhouse gas that warms the climate a bit further, and that then, so it sort of becomes a bit of a positive feedback loop, and then you switch to a much warmer state. And so that would be one of the, in these 10 oscillations that you've got, that'll be one of the peaks. So when you're looking at those ups and downs, John, do the ups happen more abruptly than the downs, or?
The ups happen much more abruptly.
Yes. So I guess this again, the timescale is quite compact here, but certainly the compared to the cool downs, the warm ups happen much faster on this particular timescale, and so you get this kind of like chicken and egg situation between carbon dioxide and temperatures. So as the temperatures go up, carbon dioxide comes out of the oceans, and this is part of the sort of the natural so the changes that are initially precipitated by variations in the Earth's orbit that happen over 100,000 years, and this creates a slight change, which then makes the Earth's oceans warm, and then carbon dioxide outgas, which then amplifies this initial change. It's kind of like called a positive feedback. Okay. And this causes like the plus or minus 4 or 5 degrees centigrade, or 7 degrees or 8 degrees Fahrenheit change. Right. So it, as it's a cyclical thing, so that once the orbit goes back to a situation where it can cool, the whole situation can reverse. So the sunlight gets distributed in such a way that the ocean currents change, so that the ocean temperatures become a bit cooler. They can then suck in more carbon dioxide, and then it sort of like the whole thing sort of starts to cool off again. We're gonna go to a sort of a graph which you can find online, and I will put the website in the show notes. It's from a scientific cartoon called XKCD. And I'll probably just like mention the web link here. It's xkcd.com/1732/.
So that's our timeline from the last 20,000 years.
Yes. So before we start looking at this plot, a few dates for you. So this time series has 20,000 years. And 20,000 years ago, it was dead cold. Like I was saying before, there was an ice sheet that was sort of half covering the UK, something like 4 degrees colder than now. So a few facts for this time series. So 20,000 years ago, the Earth was dramatically cooler than it is now. It was 4 degrees colder. There was an ice sheet sitting on top of the UK. Then things started to warm up. So this abrupt warming, so we were saying that the cool downs took a long time. The warmings up happened much faster. So this abrupt warming happens over the next 15,000 years. So all the way to about 7,000 years ago, you get this temperature rise. And then once we hit the maximum, then because of the orbits, the Earth is then in a sort of a cooling phase, and this is the slower one. So currently now we're in, believe it or not, we should be, according to the orbits, in a cooling phase.
Right.
So can you describe a little bit the XKCD plots?
Okay, so this XKCD timeline is like a kind of historical timeline from the last 20,000 years. We'll put the link in the show notes. So it starts 20,000 years ago. So as I mentioned before, humans been around for about 300,000 years. This is like the end of the last ice age. So it was 4 degrees colder then. And what we see is that there's a very, very gradual warming up across very early human history, when we see the beginnings of the ice sheets melting, which is then what enables more of the spreading of humanity. So whereas before we were living largely in Africa, this is what enabled us to spread beyond Africa, beyond the Asian, Eurasian plate, and the melting of the ice caps actually then revealed a land bridge between Asia and North America, which means that about 14,500 BC, humans were able to reach North America. So that's actually when we see the Native American tribes. When we were in Arizona, we were talking to some Navajo Indians. The Navajo Nation is one of the most successful Native American tribes in the States. They've got the largest reservation in the whole of the US. It spreads across about 3 states. And we were talking to them, and they were saying that they are ethnically related to Mongolians.
Oh, wow.
Because as we can see from this, like 14,500 BC, they were coming across from the Mongolian plateau over the land bridge, across what is now the Bering Strait between Russia and Alaska, and then coming down into North America and developing their cultures then. And so we see the warming continue. Woolly rhinos went extinct about 13,000 BC. And we see the ice sheets continuing to withdraw as the world warms until we see it hitting about 11,500 BC. And then we actually see that there's almost this slight reversal, this slight fluctuation, because from my understanding from this, as the ice melted, all of that cold water going into the oceans then may have had an impact on the ocean circulation, which then might have led to a slight cooling. But it was only like a very temporary dip, maybe of about half a degree, before it starts to increase again, until about 10,000 BC, which is when it starts being warm enough and we start developing farming as a technique. And saber-toothed tigers die out. And it says Pokemon go extinct here, but I don't think that's true.
Well, it's a sort of a comic cartoon, isn't it? So
and then these rising sea levels then cut off the land bridge between North America and Asia, so we then see that complete separation of culture there. And then it actually shows that by around about 7,000 BC, the world has warmed to about half a degree warmer than it is today.
Right. Sorry, just to correct. So the half a degree warmer than the pre-industrial period. So in 1850.
Right.
Yeah. So it wouldn't be warmer than it is today because we've warmed it by 1 degree centigrade. But yeah.
Okay. And then we see that is remaining pretty consistent with the temperature remains pretty consistent right the way through to about 5,500 BC. There was a massive volcanic eruption in Oregon. We actually visited this. It's one of the national parks. It's the only national park in the state of Oregon on the west coast, and it's just this absolutely massive hole. There's a huge crater, and it is caused by a volcanic eruption. It's about 2 miles across, purely filled with beautiful crystal blue water caused purely from snow melt and rainfall, because the elevation of it, there's no rivers that feed it at all. And this volcanic eruption was so massive. See if I can dig out the facts here. So it was so massive that the mountain that was there was about 12,000 foot high. The eruption was so massive that it blew 4,000 feet off the top of the mountain. And it actually created a 6-mile wide crater, not 2 miles. To give you an idea of how big that was, like when Mount St. Helens erupted, which is just a little bit further north than Crater Lake. That was the biggest landslide in recorded human history from a volcanic eruption, caused the entire state of Washington to go into a state of emergency when that erupted. This eruption was 40 times larger than that eruption, which is just absolutely mind-blowing, and it's still an active volcano now. So that may have caused a slight cooling of the Earth from those volcanic eruptions, but as you can see on here, like any kind of impact from these volcanic eruptions is absolutely negligible when it comes to having an impact on the global temperatures, global average temperature. And then we see that the Earth begins to slowly cool from beyond that point to the point where we get to, as we've talked about previously, the mini ice age over the course of about like 500 AD through to the start of the 20th century. But then we see this absolutely ridiculous, off the scale, rapid increase that is just completely unprecedented from the last 100 years.
So after looking at that XKCD plot, John, has climate changed before humans were around, or not before they were around, but before the advent of coal, oil, and gas?
Yeah, it has. We've seen over hundreds of thousands of years, tens of thousands of years, that there have been gentle fluctuations up and down between like 4.3 degrees below the temperatures in 1850 up to about half a degree above. But you see that those fluctuations are fluctuating from cooler than we've had it up to about where we are now. But they've been happening very, very slowly, oscillating backwards and forwards, whereas the measurable impact from the last century is significantly faster, significantly on a track, if it continues, to be significantly hotter than we've had in definitely in the last 20,000 years, if not significantly longer.
Mm-hmm. Exactly. So does that mean that the current warming is natural?
Doesn't look like it fits that pattern at all. I mean, there's quite an interesting point that it makes earlier on in the diagram, where it talks about the fact that the nature of our methodology for collecting this evidence means that we're almost taking like snapshots, and that what we're putting together from this is averaged out. But they kind of show that there's a model that if you looked at all the potential variations that it could be, those variants could only be that there was like a sudden dramatic increase every now and then, or that they vary like to a certain degree beyond the kind of frame that's shown there. But there isn't anything that would be a sudden rapid increase like what we've been seeing in the last 100 years.
Yeah, that's a very good point.
I just recommend if you're listening to this and it's not making any sense, look in the show notes, because it really does make so much more sense when you're looking at it at the same time.
Yes, and the other thing that's also worth pointing out about this is that we're currently, due to orbital variations, we should be cooling, if anything. Right. So that the people who invoke changes in orbits as a possible cause, we're in the wrong phase to be doing that.
Right, so what's next up then, Mark?
So can I get you, John, to load up this kind of article from Bloomberg that shows you some data from NASA, Goddard Institute for Space Science? Okay,
yeah, got it.
Great. So unfortunately, this used to be sort of open access, this news article. Since, I don't know, about a year ago, you have to actually pay Bloomberg to see it. But I guess we can find some what do you call it? We can get some screenshots and put them in the show notes for people who want to see what we're talking about. But John, I believe you now have access. You've got it in front of you. So the previous XKCD plot was all about climate has changed before, and giving you a bit more of a foundation in what's kind of been going on, over the last million years. Or even deeper into time than that. Now, that's only one part of the Ziggurat level 2. The world is warming, but it's not due to human causes. So the other sort of the big type of Ziggurat level 2 argument is, it's the sun, it's volcanoes, it's I think I came up with something like in the skeptical science list, there was something like 28 separate arguments I could find that were of that type. It's something else other than human-caused greenhouse gases. So next time we do an episode, we'll go into the particulars of different arguments a little bit more. But for now, again, like before with the XKCD, we're just going to give you a little bit more of a grounding in what the science says about the actual causes of the warming that's happened since 1850 or 1880, since the beginning of the pre-industrial. John, I believe you have it open.
Yeah.
Take it away. Give us a little explanation of what you see.
Okay, so there's a series of graphs that show how the average temperature has changed between compared to the 1880 to 1910 average, and it goes up till 2014. Basically, you see the pattern being that there is a significant increase, probably from about 1950 onwards, that has not shown any sign on average is coming back down. What these series of graphs do is they compare each of those temperature changes in comparison to each of the different suggested alternative possible reasons. So, for example, is it caused by changes in the Earth's orbit, as we've been discussing? Is it caused by changes in the sun's temperature? Is it caused by volcanoes? Is it caused by a combination of them? Is it caused by deforestation? Which, regardless, you could say, well, that's definitely human caused. Is it caused by ozone pollution? Is it caused by aerosol pollution? And then finally comparing it to greenhouse gases. And what each of the graphs show is that, yes, there is variance in potential temperature changes and average temperature changes in relation to each of those categories, but none of them correlate with the changes that we've actually seen, except for greenhouse gases. And those greenhouse gases demonstrate the most closely correlating change compared to what we've actually seen in temperature changes.
Great explanation, John. So essentially the way the data that's being shown here, it's kind of using climate models. So climate scientists, if they want to make some prediction about what the temperature might be like in 100 years' time, they have these very complicated computer models, and in these computer models they have to include everything that will affect the climate. So things like what's happening with volcanic activity, what's happening with land use change, these sorts of things. So there has to be some sort of, in the model, there has to be, if you emit this much carbon dioxide per year, that's going to result in this much warming. So they have to include all the factors, not just carbon dioxide, but anything that could potentially influence the climate. And of course, when we make projections about 2100, it's sensitive to how much we think we're going to emit into the future. And so obviously we don't know that, but we can make guesses, and we can have they tend to have different scenarios, one where we emit less and one where we emit more. But in any case, that's not that relevant here, because what we're looking at is past data. And so basically this is a way for climate modelers to test their models. So they have the observational data, because we have the data of what the climate's been doing since 1880, and we can then run these different models, and then we can see do we get does the model output a kind of a similar temperature change to what we see in the observed records. And so when you put all of the factors together, you do get like a remarkably close match between what the models say the temperature change should have been between 1880 and 2014. But what's clever about this kind of article is that it separates out the different components. So like the sun, for example, so the sun does have an 11-year solar cycle, so there are slight increases in activity. But then this is just one of these. There are lots of different climate models around the world. This is one that NASA uses, and so they output the component for the sun, and you don't really get like a little bits of up and down, but it's nothing on the scale of the temperature change that we're seeing. So I can't really account for it. So carbon dioxide makes the planet warm up. Did you find any components that cause the climate to cool down?
Yeah, it's quite interesting that the very final one shows a combination of all of the man-made impacts. So the greenhouse gas one actually shows a kind of trajectory that's actually above what we're actually seeing with the temperature changes we've been making caused by greenhouse gases.
So
but when you combine it with...
it predicts more temperature change than we're seeing in the observations.
Yes.
Yeah.
Yes. But then if you add in the impact of aerosol pollution, which is actually modeled to decrease the temperatures, and ozone pollution, which is also supposed to decrease temperatures, then you put those together, and what you actually see is something that almost directly correlates with what we've actually got going on.
Yes, yeah. So it's and again, this is where it's going to be a little bit of a nightmare, because we're trying to clean up aerosol pollution, and in so doing, what will happen is that these aerosols, a lot of them reflect away solar radiation. So as we stop putting them into the atmosphere, they fall out. The numbers of aerosols are going to reduce, and this is going to mean probably that we're going to get more warming, at least in the short term, as the atmosphere adjusts to the amount of carbon dioxide in it.
So actually, in a way, it's dangerous to do something about aerosol pollution in isolation, because it will accelerate the impact of CO2 in the atmosphere. We need to actually be addressing the CO2 as the priority, with aerosol pollution almost being kind of very carefully monitored so that we can bring it down effectively.
Yeah, I see what you're saying. I guess that's a little bit controversial in a way, because like with aerosol pollution, it's basically if you burn coal, you get all this shit that goes up into the atmosphere as well as CO2, and that causes a lot of respiratory problems for people.
Okay. So you can't separate them out as simply as just stopping aerosols, but you can't just do one and not the other.
Yes, exactly. But I mean, there are people who've thought, okay, so like volcanoes can, by spewing out these aerosols into the stratosphere, they can reflect away sunlight. This might be a way we can maybe temporarily get some time with climate change. However, that's a whole other debate, and I'm not going to go into that now. But sorry.
Start poking Yellowstone. That might help us out. Yeah.
Do you think it'll erupt if we poke it hard enough? Okay, just to sum up from that very cool Bloomberg post. Sorry, not post. It's kind of like an interactive article. You'll be able to see screenshots of it, but the dynamic thing is pretty impressive. So since 1880, what would you say? What factors have influenced the global climate, John?
Greenhouse gases, aerosol pollution being the primary ones, deforestation. Most of the rest of them have been pretty negligible on an impact, really. Negligible.
So the sun, for example, has had pretty much.
No, I'd say the sun is probably the most flat line across it all. Volcanoes have on several occasions led to a decrease in temperatures.
Very, very interesting. So, okay, tell me, John, we've been talking a lot about the science of climate change. Do you have any good news without the hopium? Or is it just another week of more forest fires and floods?
Well, this week's climate good news story, I've gone for something a little bit more local to us in the UK. So it's a news story from the UK. Apparently, in the first 6 months of 2023, the UK achieved record numbers of the installations for heat pumps and solar panels across the UK in UK homes. There's been a 62% rise in solar panel installations in the last year from 2022. That's averaging out at about 17,000 new installations of solar panels a month. Heat pumps. So heat pumps are a way of heating your home with a much lower carbon footprint than from gas boilers or anything like that. There were 17,920 installed in the first 6 months of the year in the UK. The government has set a target of 600,000 heat pumps to be installed by 2028. So, we've got a lot more we've got to go to in order to get to that point by 2028. So they're saying that the experts in the field are saying that we need about 50,000 experienced personnel working in the industry to be able to install all of those and meet that target. So, if you're fresh out of university, if you're looking for a career, then getting a job as an engineer installing heat pumps might be the way to go. It's going to be a growing market. You're very much needed. And then when it comes to our target for the capacity for solar energy creation, we're aiming to expand to having 70 gigatons of solar capacity by 2025. Now, I couldn't get my head around this. Do you happen to know, Mark, what is a gigaton?
Yeah, I was a bit confused by the units. Is it not gigawatts of solar? Normally they talk about gigawatts.
Yeah, when I looked up it had energy measured in kilowatt hours or a billion kilowatt hours. So I'm not quite sure how it relates to gigatons as a measure, but that's what it said in the article. So this is great because it shows that the country is really committed to addressing climate change, but also is really, really important for showing the role individual families play in creating a sustainable future for us all. And this might be a great way of engaging more people in the idea of adapting these climate saving and more sustainable strategies, because essentially by installing solar panels on your house, by having a heat pump that has a lower carbon footprint, it means it's making the UK a lot more sustainable and self-reliant. For a lot of people that are politically minded to not be motivated purely by sustainability, the idea of us not being dependent on energy sources from outside of the UK, not being reliant. I mean, I think the UK only uses about 13% of its oil and gas coming from Russia, for example. But if we can move more into onshore wind farms and having solar panels and reducing our carbon footprint through heat pumps, that's really going to help the UK to not be as reliant on foreign imports to the country, which would be better off for us. And it's saying, and again, it mentions gigatons here as well, but there's small scale renewable energy projects in the UK have the capacity to generate 4 gigatons of energy per year. So it shows that by decentralizing energy generation, by individuals going some way towards generating their own energy, it can have a massive impact on energy creation in the country and in other countries. I know my dad's had solar panels on his house for a good few years now, and yes, there was an upfront investment. And if governments can be subsidizing and supporting that, I think that will help a huge number of people be able to get solar panels on their houses. But he's really, really chuffed because when it's a lovely sunny day, he's actually paying into the grid for energy. He's actually making money from having solar being generated from the roof of his house. So it's a
Fantastic.
great, very efficient way of generating energy.
Yeah, and you're damn right about, like, so like, I guess certain people on the political spectrum would be, motivated by environmental reasons. But, for those who aren't, there are other reasons. You can save yourself money. Especially price of fossil fuels is, pretty damn high with the war in Ukraine and whatnot. And just like reducing the independence on, these different countries that supply us with fossil fuels. So there are various reasons why you might want to become, switch to renewables. Certainly.
Okay, so we're coming towards the end of this week's episode. So to sum up, this time we've been talking about what the science says about the causes of global warming over the last 150 years. We're really starting to tackle the second level of the ziggurat. We've looked previously at the arguments that global warming isn't happening. Now we're starting to tackle the idea that global warming is happening, but the argument that it might not be human caused. And we're looking directly at what has the human impact been over the last 150 years. So that's giving us a great footing to segue into next time's episode. So that's it for this week. Thank you for listening. You can find a link to all the materials that we have referenced in this episode in our show notes. Next time, we will examine what all of those wonderful skeptics, deniers, and contrarians have to say about the arguments that global warming is not man-made. We hope you'll join us then. If you've enjoyed the episode, we'd really, really appreciate you supporting the show further by leaving us a review on iTunes, Apple Podcasts, as it's known as now. You can also support us on Patreon at Countering Climate Skepticism, skepticism spelt with a K instead of a C. If you want to know more about countering climate skepticism, check out our website at ccspod.podbean.com. So that's ccspod.podbean.com. You can also send us feedback and suggestions for arguments that you would like us to discuss, or ideas for guests that we could connect with and get on the show to discuss climate denial and things like that. You can connect with us through social media. On our website, it has links to all of our different social media platforms, and can sign up to a mailing list as well. So that's it for this week. Goodbye from me, John Rainier.
And goodbye from me, Mark Prosser.
And I'm going to leave you with a quote for today from Jane Goodall, the world's leading expert on chimpanzees, no less. But this quote seemed very relevant to what we've talked about today. You cannot get through a single day without having an impact on the world around you. What you do makes a difference, and you have to decide what kind of difference you want to make. Thank you very much. See you next time.